This video is for your final review, starting on Chapter 6.4, Solving Rational Equations. Whenever you have equations that have fractions in them, best thing to do is to clear the fraction rather than getting a common denominator. Of course, to clear the fraction, you're going to have to get a common denominator anyway, but instead of getting, say, a 2x under here and a 2x under here, I'd rather just get rid of all of them together. So, common denominator, as we said, is 2x. I'm just going to multiply both sides by 2x. That way here, 2x's cancel, and I have to distribute here. If I multiply 2x to 1/2, the 2's cancel, and I just get left with an x on top. And if I multiply the 2x to the 2 over x, the x's will cancel, and it'll be 2 times 2, which gives me 4. That all equals 3, and if I add 4 to both sides, I just get x equals 7. Next, if you have 4 over a minus 7, negative 2a over a plus 3, there's nothing in common with them, but we can still use the same principle that we used before and multiply by the common denominator. In this case, the common denominator is both of these things together. A minus 7, a plus 3 over 1 over 1. That way a plus 3's cancel, and I can cancel these because these are all multiplying. Cancel my a minus 7's, and I just have 4 times a plus 3, which is 4a plus 12. And the negative 2a times a minus 7, which is negative 2a squared plus 14a. If I have an a squared, I need to get everything over to one side. That way I can factor. So I will add a 2a squared and subtract a 14a from both sides, leaving me with a 2a squared minus 10a plus 12 on this side, 0 on this side. The 2's will come out, and then I can just factor. And this 2, not going to mean anything, so I just have an a equals 3, a equals 2. Up here I just want to check and make sure. This a minus 7 is a restriction, so I know that a cannot equal negative 7. A can also not equal positive 7. And that can't equal negative 3, because those are the two things that will make the denominator 0 somewhere in this equation. So both of these answers are correct. For my next problem, y squared plus 2y, I actually do have a common denominator here, because if you notice, y times y plus 2 is actually equal to y squared plus 2y. So if I multiply both sides by y plus 2, this side actually will cancel because they are actually the same thing. This side equals 4, and distributing, the y's will cancel here, so I end up with a 3 times a y plus 2. The y plus 2's cancel on this one, so you just get y times y, which is y squared. So rewrite this: y squared plus 3y plus 6 equals 4. Subtract 4 from both sides. Y squared plus 3y plus 2 equals 0. Again, I'm going to factor. Y plus 1, y plus 2 equals 0. And that means y equals negative 1, y equals negative 2. Check back, check my restrictions. Y can't equal 0. And y can't equal negative 2. So that means that this cannot be an answer because of this. So y can only equal negative 1. The next problem is one of the work problems. It says that together it takes 4 hours for Walter and Cora to clean up their garage. It takes Walter 6 hours longer to clean it himself than it would take Cora. How long would it take him to clean it alone? So one, I know that it takes them 4 hours together, and Walter 6 hours longer to clean it himself. So it takes them 4 hours together, Walter 6 hours longer than Cora. I'm just going to let x equal hours it takes Cora, making x plus 6 equal to Walter. The equation that I'm going to use here is t over a plus t over b equals 1. This means that they're going to do one job together. These two t's represent time together. This is first person alone. This is the second person alone. And then again, the reason the 1 is there because they're really just doing one job together. So for time together, I see that it takes them 4 hours together, and that means there's a 4 on the top of both of my equations, or terms I should say. A is going to equal first person alone, let's call that Cora. Second person alone is x plus 6. Now I have an equation just like I had in those previous problems. I'm going to multiply both sides by a common denominator, and it's not just x plus 6. You have to multiply both x and x plus 6, because there's nothing you can multiply x by to get x plus 6. Multiplying, distributing, x's cancel, so I just have a 4 times an x plus 6. X plus 6 is cancel, I have a 4x. That's equal to x times x plus 6, which is just x squared plus 6x. Here's 4x plus 6, 24 plus 4x equals x squared plus 6x. Subtracting from both sides, together here I have 8x. I'm going to subtract 8x from both sides. And I'm going to subtract 24 from both sides. So 0 now equals x squared minus 2x minus 24. Factoring gives me x minus 6, x plus 4. And the only thing this could be, because this would equal a negative 4, x must equal 6, because it's got to be positive. So if x is 6, then it takes Cora 6 hours, and Walter's x plus 6, which is what the problem was asking for, and that's 12 hours. When I have these distance rate problems, I always set up my box where distance equals rate times time. Sometimes I'm comparing two people with each other, sometimes I'm comparing with and without the wind. I also want to remember that just by dividing things to both sides, if I divide rate by both sides, then time's going to equal distance over rate. Rate's going to equal distance over time if I divided time by both sides. Looking at my problem, it says that Adrian rides his bike at 50 miles per hour with no wind, then 35 miles against the wind in the same time that it takes to bike 140 miles with the wind. So I know that I'm comparing against and with wind. Alone, it says it takes him 15 miles per hour with no wind at all. So that means against the wind, that we don't know yet, you have to subtract how fast the wind is going, and with the wind you're going to add how fast the wind is going. The distance that it takes that he can bike against the wind is 35. It's part of the problem, and 140 with the wind. And the time is something we don't know, but we do know that because it's the time that it takes him to ride 35 is the same as 140 with the wind, then you know that these two times are equal to each other. I also know that since time is equal to distance over rate, I can really just substitute this, because that's distance over rate on this one, that's distance over rate for the lower one. And since these times must be the same, here's my problem. Just going to set them equal to each other. Same as before. Multiply both sides by your common denominator, which in this case is 15 plus w, 15 minus w. 15 minus w's cancel here, 15 plus w's cancel here. And I have 35 times 15 plus w. And 140 times 15 minus w. This is going to equal 525 plus 35w and 2100 minus 140w. Just get things to one side. I'm going to add 140 to both sides, and that's going to equal 175w. I'm also going to subtract 525 from both sides, and that gives me 1575. And by dividing both sides by 175, W equals 9. So the rate of the wind is 9. Next we have 3 examples of what you would do to divide polynomials. It really depends on what you're dividing by. Here we have a division by one term. Here we have a division by 2 terms, where it's just an x minus 2, and the next one we have division of an x squared minus 2. You can do different things with all of them. If you just have one term, the best thing to do is just individually divide them all by this term. and just start canceling. So here, one of my a's cancels, and the 6 cancels. So I just have negative 3a squared. Negatives cancel here. A bunch of things cancel out, and you're down to this. The next one, I'm going to show you synthetic division. You can also do long division on this problem like we're going to do with the next problem. But with synthetic division, if you have an x minus 2, it has to be an x, not an x squared, not an x cubed, just an x and a minus 2. I'm going to change the sign of the 2, put it in my box, and just take the coefficients of each of the rest of my terms. If there's a term that's missing, like if, let's say, it went x to the 4th, x squared, x, and 3, I was missing an x cubed, so I would need to remember to put a 0 in. Not missing a term this time, so I'm just going to put all of my coefficients lined up. Those coefficients you add down. So 1 plus 0 is 1. You're going to multiply that times 2, which is what's in that box, which gives me a 2 here. Add down, so I get a negative 5. Multiply by 2, which gives me a negative 10. Add down, which gives me a 3. Multiply by 2 to get a 6, add down to get a 9. Now what do all of these numbers mean? This 9 is my remainder. Remainders always go over what I had to start with. And then over here I'm just going to call this just a number on its own. This is going to be something with an x, and then this must be something with an x squared. So I just go x squared, x, no x, and then remainder here. If you're going to do long division, I'll show you that on the next problem. You are going to try and see how many times this first term here will go into this term here. Well, what would I have to multiply this to get this? I know that I need another x squared, because x squared times x squared would make x to the 4th, and I would also need a 3 here. Multiplying both, I get 3x to the 4th, and multiplying over here, I get negative 6x squared. I don't want to put that here. I want to put that underneath the same term. That way, when I subtract, get 0. This gives me negative 11x squared plus 6x squared, gives me a negative 5x squared, and 2x cubed minus nothing is 0. How many times does x squared now go into 2x cubed? Well, I need another x, and I need a 2. Multiplying, I get 2x cubed, and over here I get a negative 4x. Not x squared, I get a negative 4x. So I'm going to bring this one down, and again I'm going to subtract. Negative 2x minus a negative 4x gives me a positive 2x. There's nothing to subtract here, and this gives me 0. One last time, x squared goes into negative 5x squared, negative 5 times. Negative 5 times that is negative 5x squared. This gives me a positive 10. Right? And when I subtract, bring down this 5. 5 minus 10 is negative 5. 2x minus nothing is just 2x. And this is my remainder because x squared can't go into 2x any more times. So I'm just going to leave that 2x minus 5 over my x squared minus 2. That's going to be plus. So here's my answer. For direct, indirect variation, if it says that y varies directly with x and z, direct always means on top of the fraction. So sorry, y equals, and k is going to be some constant, and k is really what you're trying to find here. Varies directly, x and z, that means they go on top, and inversely with w, w goes on the bottom. I'm just going to plug in numbers to find out what k is, because k is considered my coefficient of variation. It's what I multiply by. So y equals 3, when x equals 6, z equals 4, and w equals 5. So 3 is going to equal 24 over 5k. I want to get k by itself, so I'm going to multiply both sides by 5 over 24, the inverse. Cancels. The 3 and the 24 are going to cancel to 1 and 8. So I really have 5/8 equals k. My equation of variation then is anytime you have y, you're just going to multiply 5/8 times xz over w. And that's my equation of variation.